Okay, guys, like the song said, welcome back. Let's go with start with the land acknowledgements. Let me just get my screen ready here. Okay. By the way, can you guys hear me? Just type in the chat. Can you hear me? Okay, that's good. I don't know why so many people are away today. It's very interesting. But we'll start anyways. We acknowledge we are hosting the lands of the Mississauga of Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize enduring presence of all First Nations, Métis, and Inuit people. Okay, today is Thursday, August 15th. Today is day 11. Like I said, it's going quickly. Yesterday was day 10, day 11. So for today, just so you know, tomorrow we're going to be giving out the Unit 4 test. Okay. So there's 3 parts. We'll be giving out tomorrow, Friday, on August 16th, and it will be due on Friday, 11:59 p.m. Okay, so it'll be open at 12:01 p.m., like later on, at midnight tonight, and it will be due Friday at midnight. Okay. Again, we're going to continue with Unit 4, periodic behavior, periodic functions, transformations. All of this dealing with trigonomic functions. We got 3 or 4 worksheets you can do to practice. And then there's a quiz on the above lesson. And then there is a practice quiz over here, which does not count for marks, but it's good for you to help you to get ready for the test, which will be given out tomorrow, okay? So let me actually look at this from you guys' perspective, from a student, making sure all the links work. Let's look at it from you guys. Okay. So I'm going to click on that. Won't work because it's going to be available tomorrow. Let me make sure the quiz works. Looks like the quiz works. Okay. The other thing is the practice quiz. Let's see if that works. Practice quiz works. Okay. And then let's see what else. Worksheets. I won't click on that. We'll just go into content. We'll see from there. Go into content. Unit 4. So Unit 5 is seats right there, right? Unit 5, we're starting tomorrow, by the way. So today's the last day for Unit 4. See how quick that's why you got to do all the tests. People want to hand in Unit 2 test like today, when it was due like a week ago, and we're already about to do Unit 4. Can't do that. It's like you're not going to pass the course if you do that. So you got to hand the unit test on time when it's given, because there's like 3, 4 right after. Okay, so you guys are fine. I won't talk about that anymore. So today is the 15th. So we're looking at what's today, periodic behavior. And then here's the worksheet for that. Then we'll talk about graphic periodic functions. And then there's a worksheet for that. And transformation. And there's a worksheet for that. Application. There's a worksheet for that. So let's go to the first one, the 15th. Looks like there's no video for this. So I'm just gonna have to explain it without a video. So let me get my pen. Okay, so we're talking about periodic behavior. So let's click on a lesson. Okay, so when we talk about periodic behavior, let me zoom in. Okay, so we're looking at basically when we're talking about periodic behavior, you will have a sine curve, okay? And here I'll use blue. And this would be a cosine. Okay, so what we're looking at, I'll use a different color. It's use green. From the definition, we have some definitions we want to look at, right? And from the definitions, you can see what is a periodic function. What does it say? It says a function that has a periodic, has a pattern of y values that repeat under regular intervals. So what does that mean? So here, if I look at like my graph here, you can see here, it repeats when I get to here. If I look at the red curve, right? If I look at the red curve, you can see that's the graph. But once I get to this point here, then it repeats, right? Then you see it repeating again. I'm just gonna go off the screen a little bit. See, it repeats at this point here. Okay, so when it's saying y values, yeah, the y values repeat after this point here. Now then, this is a cycle. A cycle is one complete repetition of patterns. So a cycle, use a different color here, purple. So a cycle for the red curve, which is going to be, you'll know it's the sine curve, from there to here. Okay, that's a cycle. To do one complete pattern. Okay. So when we say one complete pattern, so I started off here, and I come back, and then I get to here, and I'm going to repeat the pattern. So that's one complete cycle. Now the period is, it says here period, that's the length of time maybe for one cycle. So the cycle is from here to here, and then that is called a period. Okay, that's the distance, the length of time maybe for the whole cycle. Okay, now amplitude, we talk about amplitude. Amplitude, use red, is the max distance between like we're talking about half the distance, right? So from here to here, that's your amplitude. And then from here to where the graph, I think it's right there. So it ends like here. So from here to here, from here to here, let me just erase this little part there. Oops, I don't want to do that. Okay, from that distance to that distance, that's your amplitude. Okay, so we got the basics. Okay, so now we're gonna look at start looking at examples here. Let's continue. Let me just clear my screen. So we're gonna scroll down. So here's example one. So if you look at this curve is your periodic function, but you can see when I look at it, when it gets to here, oh, then it repeats. Okay, so because it repeats from here, now I can look at it from here to here is my period. That's my distance. Okay, from there's my distance. For my period is going to be from 0 to -6. My distance is my period is going to be 6. Maybe it's time, maybe it's degrees. It all depends what that is. Okay, and then my amplitude is basically from the max and the min, the half distance. Okay, so that's basically, first of all, that's your period. So let's look at that. Let's look at another example. The question is, determine whether functions are periodic or not. and state the period of the function. Well, if we look at this one, this is periodic because we said it repeats after this many that distance. So here's a cycle, and one cycle is determined from there to there, and basically it repeats again. Here, there's no repetition from anywhere. You can't see any kind of pattern. So therefore, it's not a periodic function. If you look at this one here, this example here, it says, is the function periodic? And if so, what's the amplitude? Well, let's look at it. Does it repeat? Looks like it repeats. I see patterns here. So since it repeats, now what's my max and min? Here's my max, here's my min. And my amplitude is basically the halfway distance between my max and min. Okay, the halfway distance. So what you want, and then how you calculate that is basically add your max or subtract your max, your min from your max, and then divide that by 2. So my max here is 3. My min here is -1, subtract the 2, then divided by 2. Therefore, my amplitude is 2 units, okay? Looking at this one here, it's saying determine the period and the amplitude. Well, the period is you got to see when it repeats. You go from here to here, and then it repeats again. So it looks like I got to stop here. So from here to here, that distance is -1, -7. So the difference between that is 6, right? So my period is 6 units. Now my amplitude is going to be, well, I'm going to have my max at 3, my min at -2. So 3 minus -2, then divide that by 2. So my amplitude is going to be 2.5 or 5 over 2. Okay. So now let's look at this one here. For the following function, which we see here, predict values of periodic. So for the following, basically it's saying here, determine f of 5 and f of 2. Well, I can look at a graph and see what that is. So when x is 2, what is y? Because f of 2 just means what's the value of y when x is 2? Well, when x is 2, y is 1. When x is 5, y, when x is 5 over here, y is 0, which would you see over here, okay? So look at it now, when x is 8, what is y? Okay, well, when x is 8, where's 8? It's off the graph. Interesting. It's not showing on the graph. So what do? We're stuck. Well, what you can do is predict what that would be. You need to know what is the period. If you know the period, so when does this repeat? So the period is, I go from -1 to +5. So -1 to +5. It looks like my period is 6 units. So every 6 units, it repeats, right? So every 6 units, it repeats. So what I would do is, instead of looking for 8, when the value, what's y when x is 8? Okay, what I can do is, some people still need to join. Let me get them in here. Okay, so when x is 8, we want to find when x is 8 and when x is -10 and x is 14. We can figure it out because we know the period, okay? So the period repeats every 6 units, okay? So if I am looking at what when x is 8, well, x is 8 is off the graph. So let's look at it when, let's go 6 periods or 6 units to the left to get into the graph. So if I start off at 8, so 8 minus 6 gives me 2. Okay, so now I'm going to look at 2. So 2, the value of when x is 2 is going to be the same when the value when x is 8. Why? Because we said it repeats after 6 units. So if I start off at 2, and if I add 6 units, then it's going to repeat again. So the value at 8, when x is 8, it's going to be the same value as when x is 2. So what was the value when x is 2? When the value when x is 2, it was 1. So the value of, there you go, the value when x is 8, it's going to be 1, right? Because it repeats every 6 units. So I can guess now when it says, well, when x is minus 10, I can, because minus 10 is off the graph. So I want to get into the graph. So let's say when x is 10, I can't see it over here, or minus 10. Let's get it onto the graph. So when x is 10, let's add 6 units to that because you know it repeats. So minus 10 plus 6 gives you minus 4. Okay, at minus 4, so the value of y at minus 4, when x is minus 4, is going to be the same when x is minus 10. So at minus 4, x is what? X is 1, right? So when I go to here, there you go. X is 1. You can see the pattern? If I'm saying x is 14, what would be the y for that? Well, 14's off the charts, way over here. So I'm going to count back 6 units because it repeats. I want to get back into the chart. So 14 minus 6 gives you 8. That's still too much. I still can't see it. So 8 minus 6 brings you to 2. Okay. So when x is 2, y is 1. When x is 2, that's the same as when x is 14. So when x is 2, y is 1. So when x is 14, y is also going to be 1. Let's see. Here we go. Drum roll. There you go. X is 1. Sorry, y is 1. Okay, it repeats. Okay, so that's how you do that. So now here, determine the values of x so that f of x equals to 2. So what's it saying here? What is the value of x when y is equal to 2? That's what we're saying here. Because f of x just means y, right? We know that. F of x means y. So if y is equal to 2, that's what we're saying here. What is the value of x? So let's go to the graph. When y is equal to 2, when y is equal to 2 is right here. What's the value of x? 0. When y is equal to 2, x is 0, right? So there we go. Let's go. There you go. Okay. And so on. Okay. So let's look at this example here. A cutting machine chops strips of plastic into their appropriate lengths. The following graph shows the motion of the cutting blade on the machine in terms of time. So here shows you a periodic function. It shows you the blade comes down, looks like it comes down when you look at it. It repeats, right? So to make all the lengths of the plastic the same, when it's traveling like this, okay, when it's traveling, and I'm using my hands. I shouldn't use my hands. I was just when the plastic's traveling like this, okay, it's coming down at the same time. So it's gonna make the plastic the same length every time. Okay. So what's the time the time it takes to come down, come back up, and then do that again is the period. So what is the period? The period, if I start up here, wait, come back down, come back up. Okay, so my blade's up here. I'm waiting, comes down, comes back up. So that's my period right here. So from here to here is my period. So let's look at it. I started off at 4 and it repeated again at 8, right? So my period is going to be 4, okay? So it's saying here, now let me clear my screen here. So what's the first thing? It's saying the max height of the blade and the minimum height. Okay, well that's basically, it's telling you in the question. Well, not even a question, in the graph. Okay, my max height of the blade is 0.5 and my min height is 0, right? Which makes sense. The blade is 0.5 centimeters above the plastic. And then that's the max height. And the minimum height is when it hits the table. So that's 0, okay? So that makes sense. So my max and min, 0.5 minus 0. We're trying to find the amplitude. The question is trying to find the amplitude. So it's going to be 0.5 minus 0, divide that by 2. My amplitude is 0.25 centimeters, okay? Now saying here, what is the period of the function? Well, when does it repeat? You start off here, and you start off at 4, and it repeats again at 8. So the difference between the two there is going to be 4. So my period should be 4, right? There you go. My period is 4. Now then it says here, state the next 2 times the blade will strike the cutting surface. Well, it strikes the cutting surface every 4 seconds. So let's look at the graph. So it's saying when does it strike the cutting surface? So that means when it strikes the cutting surface, my height is 0. So when is my height 0? My height is 0 at 3.5, 7.5, and we know it repeats every 4 seconds. So if it says 7.5, that means it's going to repeat at 11.5. It's going to repeat at 15.5. Okay, so that's when it's going to repeat. So it should tell you that right here, right? 11.5, 15.5. Okay, so it repeats every 4 seconds. Okay, so we just finished periodic behavior. We just finished that one there. Okay, so let's go on to the next topic. And then there's a worksheet for that. Graphing periodic. This looks like there's a video here, so let's look at the video. Okay, we're gonna look at the video for now and go through that. Gonna mute the commercials first.
Responding to email.
Let me maximize the screen. Okay, give me a second, guys. Okay.
Ratio, sine, cosine, tan to the unit circle.
Okay, with this one here, we are linking what we know about
Trig ratios to this unit circle.
Okay. I need some water. Give me a second. Okay, sorry about that. I just need some water. I think I'm okay for now. So what we're doing is we're linking the periodic function with the unit circle. Okay, the unit circle, okay, is related to the trigs, right, from the previous lesson. So let me play the video, and then I'm gonna pause when it needs to be paused, and emphasize some things here.
Let's look at how we can relate the primary trig ratio, sine, cosine, tan, to the unit circle. Remember, a unit circle is a circle centered at the origin with the radius of 1. How we can relate the three primary trig ratios to this unit circle, and then use that relationship to help graph what sine theta and cos theta actually are going to look like graphically. So we'll graph sine theta in yellow there. We'll graph cos theta in green down here. But first, let's remember the relationship between the primary trig ratios and the unit circle. So keep in mind, three primary trig ratios are sine, cos, and tan. And you know the word SOHCAHTOA tells you that sine of any angle is equal to its opposite side divided by the hypotenuse. Cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. And this was used for when you had right triangles where your reference angle was in here and the reference angle was less than 90. And that reference angle we could label our opposite, adjacent, hypotenuse. So this is great when your reference angle is less than 90. But the unit circle can be used to look at the relationship between angles and the trig ratios. When we have angles anywhere between 0 or 360, we could even use negative angles by rotating clockwise. Or we could do angles bigger than 360 just by continually rotating around this unit circle. So how are we going to use this unit circle to get a new relationship for the primary trig ratios? So first of all, remember that the initial arm always starts along the positive x-axis here. And then our terminal arm is going to rotate counterclockwise around. So we could draw our terminal arm is going to rotate.
Okay, so what we're doing here is you're gonna start seeing here when he draws this triangle here, right? You're gonna see like it was in the unit circle, right, from before, right? So he draws this out like that. Here's your right angle triangle, right? This is your x over here, and then up here was your y, okay? And basically, and over here it has your angle, okay? Inside there was your angle, okay? So when you look at that y, I shouldn't say like that, but y, sorry, remember this is a unit circle, so that means r is your hypotenuse over there, okay? And then your hypotenuse is equal to 1. The key is the hypotenuse is equal to 1. It's a unit circle, right? It's key, it's equal to 1. So anything over, so if I want to find the cos or the sine of this, remember y is your opposite, and then your x here is going to be your adjacent, right? So if I want to find the, if I say I want to use sine, that angle, sine theta, right? It's going to equal to y over 1. Y over 1 is the same thing as y. If I want to find cos theta, is going to equal to x over 1 because 1 is your hypotenuse, which just means just going to equal to x, okay? So if we want to do that, right? So from here to here, that's my x. I can find it out by using cos theta. From here to here, that's my y. I can just use that using sine theta. So that point there, that point right there, what I'm just circling, is basically made up of, right, your x and y. And your x is cos theta, and your y is sine theta. Okay? So this here applies to any point along here. Okay? So if I want to find that, I can use my cos theta for my x and my sine theta for my y because the r is equal to 1. Okay? And that will basically help you find the angle. Okay? So that's what he's going to talk about. Then we're going to relate that. You can see here it's 1 on this graph here. It's 1. And over here is -1. We're going to get to that. It's all in our unit circle. So let's continue.
Some angle, we'll call that angle theta, from the initial arm in a counterclockwise direction. Now it's going to intersect the unit circle at some point xy here. Now if I were to make my right triangle by connecting this back down to the x-axis, In this right triangle, this side, well, let me just erase this here so you can better visualize this right triangle. This side has length.
So I just erased what was there so you can see he's going to do the same thing which I just did. So when you watch the video, you can play it back if you want to see, but I'm just erasing to make it clear.
X, right? Because to get to this point here, we would have had to travel X units that way and then Y units this way. So this side has length Y. And this side, the hypotenuse of the right triangle, is the length from the middle of the circle to a point on the radius of the circle. So this, since it's a unit circle, the radius has a length of 1. So we can rewrite our primary trig ratios in terms of x and y. So sine theta would be equal to the opposite side, y.
Right, and then he's going to say y over 1. Again, that just means sine theta equals to y, like I said.
Over the radius of 1. So
I'm going to fast forward just a little bit because I already said that, so we can just kind of see. And then cos theta is going to equal to x over 1. Okay, there you go. So y sine theta equals to y, and then he's going to do cos theta. Cos theta is equal to x over 1, which just equals to just x. Okay.
just x. So cosine actually just tells you the horizontal distance you are from the y-axis. So let's use these relationships so we know that sine theta equals 1 and cos theta equals x. Sine theta equals 1, cos theta equals x. So let's use that relationship to be able to actually figure out what the ratios are going to be at some key points as we rotate around this unit circle. So let me just get rid of all this. So
okay, so he just erased all that to show you all the key points, okay? So here we go.
We are going to start along the initial arm along the positive x-axis. So that is going to intersect the unit circle right here at the point 1.
Okay, so it intersects, remember we said all of these is going to be related to sine theta and cos theta, right? Your x and y is going to be related to sine theta, cos theta, okay? So at that point there, where you have it, it's going to equal to, because this is a unit circle, and this is my x and y graph, you can see there, my x is 1, my y is 0, right? Okay, and then we're going to go around. I'll play it from here so you can hear what he's saying.
And as we rotate 360 degrees around this unit circle. So if we are going to find the ratio for sine theta, remember sine theta is always equal to y. So if I want sine of 0 degrees, I just need,
well, sine of 0 degrees, if I'm saying this, look at this, there's no angle here, so it's 0 degrees, right? So sine of 0 degrees, we know sine theta equals to x. So that point there says it's 1 comma 0, and the x component there is 1, and my angle is 0. That means sine of angle 0 equals to 1. That's what that means, okay? And you'll see there. Oh, my bad. I'm saying sine, right? My bad. It is sine, but sine is related to y. So just rewind what I just said. Sine is equal to y and cos is equal to x. So if sine of the angle is 0, that means this point there, if it's 0, the value is 0, that means sine of angle 0 equals to 0. Okay? There you go. And then we can talk about cos now. Oh, we can go all the way around actually. So he's going to do this. So at that point there, what's my y up here? My y up here is 1. Okay? Up here it's 1 where my mouse is. Over here, my y is 0. Over here, my y is -1. Let me write on here. Okay? So right up there. Okay? So we'll put points there. So you know that's going to be 0 and 1. And over here, it's going to be 1 comma 0, but actually it's -1. And over here, and I'm putting in those points there. That point there, and that point there. So that's going to be 0 comma -1, right? So if I label it like that, then I'll know what are my sine ratios for those angles, because I'll know what that point is. Okay, so look, if I look at sine 90, and remember 90 sine, sorry, I should say, is related to the y component. So sine 90 should equal to 1, right? Should equal to 1, right? There you go, equal to 1. Sine 180 is going to equal to 0, if you want to do that. All the way around. Sine 180 equals to 0, like I said. And then sine 360 should equal to 0 again, because I'm going to go back to 0. Let's do sine 360. Follow this plate from here.
So the ratio, when we rotate 180 degrees, is back to 0. How about when we've rotated from the initial arm, when we rotate 270 degrees? So the terminal arm is now going to intersect the unit circle right here at the point.
Right, so here our y is -1, so 270 means, sine 270 means it's equal to, sorry, not 1, -1. Okay, it's equal to -1. There you go, -1. Okay, and then you're going to do, now the last one's going to be sine of 360. It should equal to 0. Okay. He doesn't really plot that because we just already know that. So now watch, he's going to plot all these things here on this graph here, and you'll see something. Watch.
If we rotate 360 degrees, that's going to be coterminal with 0, which means we're back to the same point right here, 1, 0, which has a y coordinate of 0, so the ratio is back to 0. If we,
I forgot to mention, all these points, if you plot them here on this graph here, you're going to see it repeats when it got back to 360. So if you were to graph this, which I'm showing you right here, it looks like this, right? So again here, oh, it repeats. So my amplitude, sorry, my period or cycle was from here to here. So my cycle was 360, my period is 360, okay? And that's for the sine of all these values, okay? That's what that looks like. So let's continue.
connect these points, I mean, we could find points in between these, maybe using our special triangles. You would figure out that it's actually going to form a curve like this. Points are going to be connected by this smooth curve. And this is what the graph of sine is going to look like. Now, and it's going to continue. Remember, this function is periodic. So this pattern of y values oscillating between 1 and -1 is going to continue every 360 degrees.
Okay, it repeats. So now we're going to look at the cos, and the cos is going to be similar. Okay. So we have 90, 180, 270, and 360. Now you're going to look at all the x values, because cos theta is equal to the x component, right? On this unit circle. So all my x, so at cos 0, my y is 1. At cos 90, sorry, I shouldn't say that. At cos angle 0, my x is 1. At cos angle 90, my x is 0. At cos angle 180, my x is -1. Okay, and you can see the pattern. So he's going to plot that, right? He's plotting 1 first, then he's going to plot 0, and then he's going to plot -1 for the 180. There you go. And then for the 270, he's going to plot 0. There you go, 0. And then when it got to 360, it repeats again. Okay, so that is graphing sine cosine. Okay. So we're done with that. And then there's a lesson on that, which is, it matches the video we just watched. There's a worksheet there. So let's look at the transformation. Now transformation basically is like all the other transformations. We have a, we have a k, we have a d, and we have a c. Same thing transformations we had with the regular functions that transform quadratic, then also transform exponential. Now we're going to also transform periodic. Okay, so let's look at that. There's no video here, so we're going to look at the lesson. Let me clear my screen here. Zoom in a little bit. Maximize the screen. Zoom in. Okay. So here is for our transformation. Again, you can transform either a sine or a cosine. Okay, doesn't matter, but that's your equation there. And then you also have an A. Now here, what the breakdown is: A is your amplitude, right? Again, A also deals with stretch and compression vertically. K is related to your period. So your period is equal to 360 divided by K. Okay. And K is like either a horizontal stretch or compression. Okay. By a factor of 1 over K. So 1 over K will give you either a stretch or compression horizontally. We know that from before, and that's not new. D shifts it left and right. We know that from before. C moves it up and down. So we know all that's from before. So let's look at our basic parent function. Because here we all have a parent function, right? Here, the parent function is sine theta. Over here, the parent function is cosine theta. We know that from the previous lesson. This is our sine theta. That's what it looks like, which is the parent. That's the parent graph. Here also is the other one, the cosine. Okay, we know that from the before. Okay, so now let's look at a shift here. This one here shows you the shift, the transformation. I have now it's y is equal to 2 sine x plus 1. Okay, well, we know x is just our angle variable. So I know over here we say, what do we say here? Oh, we use sine x. Okay. But and the previous one we used the unit circle was this y is equal to sine theta, but x is the actual angle. Okay. So we're looking at the angle. So 2 sine x plus 1. Okay, well, since a is greater than 1, you know, it's a vertical stretch. Okay. And I have a plus 1. That means it's going to lift everything up. So whatever I have up here for my parent function for my sine, okay, this is right here, I'm going to apply the transformation to it. So what does that mean? If I know my x and y values here, I'm going to apply the transformation. So every y value, x looks like there's nothing happening to x. X is going to stay the same. But every y value, I multiply by 2y, and I add 1. See how it changed? So now when you look at the graph, so the graph stretched vertically and it moved up. Okay. So there you go. Let's look at another example. So that, well, not just yet. Let's look at our amplitude is our A, which is 2. Our period is 360. It's going to ask the question, what's our amplitude? What's our period? Right? That's the question. What's the amplitude? What's the period? And number of cycles between 0 and 360. Okay. Well, amplitude is, someone wants to come in. Amplitude is 2. Our period is, the formula is period is equal to 360 divided by K. So therefore our period is equal to 360. And the number of cycles between 0 and 360, well, it's only, I just put in there basically our period is 360. So therefore I can only have 1 cycle in between, right? So that makes sense. Okay, let's look at another example. With this example here, okay, here is minus 1.5 cos bracket 3 bracket x minus 3/6 or minus 30 bracket plus 0.5. Okay, so what do I see here? Please mute, please. Someone is making some noise there. Mute your, okay, thank you. Yeah, so what happens? Well, our A is negative 1.5. So the 1.5 tells me it's going to stretch by a factor of 1.5 vertically. The negative means it's going to reflect about the y-axis. So whatever value I have for y, I'm going to multiply by a negative. So it's going to be a negative 1.5. Now my k, what's the value of my k? My k is 3. So remember, if it's 3, that means the factor is 1 over the 3. So 1 over 3 is a fraction still. So that means it's going to be a compression. So that means it's going to be a horizontal compression. So each x value I'm going to divide by 3. We know that. Now here I have 30 degrees. So that means it's 30 degrees is going to the right, but it's a positive 30 degrees. So therefore it's going to go to the right. So every x, I'm going to add 30 degrees to it. And then my y is 0.5. So every y, I'm going to add 0.5 to it. Okay? So that's what happens there. Okay, so what I'm graphing here is my parent function of the cos x. So what I'm going to do is apply the transformation. Every x value divided by 3, I'm going to add 30 degrees. And every y value, I'm going to multiply by negative 1.5, and then I'm going to add 0.5. So that's what I get. So if I were to graph the transformation function, it looks like this. Okay, my amplitude is 1.5. My period is, if that's the question, they ask you what's your period. Your period is, don't get confused with period and just K, right? Because you need K, or if it's a horizontal compression or horizontal compression or stretch. Okay. Yes, you need your K. You need your K for 2 places: to figure out if it's a horizontal stretch and compression, and then you need your K value in order to figure out what's the period. Okay. So the period is 360 divided by K. Therefore, the period is 120. Okay. Now I ask the question, if my period is 120, well, what's the number of cycles between 0 and 360? Well, the period is 120. So how many times 120 can go into 360? That's your answer. So my answer is going to be 3. Okay. Here is another, this is going to be the last example we're going to look at. Here is a transformed function of the sine. Okay, if I look at it, my A is 1, so therefore there's no stretch or compression with A is just equal to 1. My K is negative 4. The negative means it's gonna flip about the y-axis, reflect around the y-axis. Okay, horizontal. But then I have a K value of 4, so that means my factor for stretch or compression is going to be 1 over 4. Since it's 1 over 4, that's a fraction. Therefore, it's a compression. So a horizontal compression of 1 over 4. And therefore, each x value, I'm going to divide by 4 and multiply by negative. Okay. Now my D is going to equal to 60, but that's a positive. So 60 degrees shift. And then my phi is going to add 2 degrees. So therefore, every x value, I'm going to add 60 degrees, and every y value, I'm going to add 2 degrees, or 2, value of 2. So there you go. Right? So here's my parent function here. Here's my transformed. I do this. I apply the transformation to each component, x component, and I get a new x component. Apply the new transformation for the y, and I get a new y. Okay? And then my amplitude, asks you there, what's your amplitude? Well, my amplitude is 1 because I don't have a value of greater than 1, so it's just 1. And my period is, remember, it's 360 divided by K, so my period is going to equal to 90. How many times I can get 90 into 360? That means how many times I can repeat that graph? Well, I can repeat it 4 times, okay? Okay, so that is that one there. Let's look at the last lesson. Okay, here's the worksheet. Just check your understanding there. Here is application. We'll look at a couple application questions. And then we're done. We're done with unit 4. Tomorrow we start unit 5. Okay, so that's how fast we're going. Unit 5 starts tomorrow. So tomorrow you start unit 4 test. So let's look at this. Okay, so this is just a repeat. We remember this unit circle. Okay, unit circle r is equal to 1. That means sine theta equals to y, cos theta equals to x. Okay. Since we're talking about unit circle, that's what we get. So then tan theta is going to equal to y over x, right? So it says here, things we should know. Sine function, graphs, the relationship between the angle and the vertical displacement of x. Okay, so when we're talking about a vertical displacement of x, a vertical displacement from the x-axis, we're going to use sine. When we're talking about a horizontal displacement, then we're going to talk about y. Okay, so based on a question, you can either talk about the x or talk about the y. Horizontal displacements, you use cosine. Vertical displacements, you use sine. So let's look at this question here. You are in a car of the Ferris wheel. Okay, the wheel has a radius of 8 and turns counterclockwise. Let the origin be at the center. Begin your sketch where the radius from the center of the wheel to your car is along the x-axis. Okay, so here's my Ferris wheel. Pretend that is. My center is here. The Ferris wheel has a radius of 8. That means from here to here it's 8. From there to there is 8. From there to there is 8. From there there's 8. So if this is a circle, we'll turn this into a circle on a graph. So this distance here, that's your x. My x is going to equal to 8. My y is 0. Over here, my x now is 0. My y is 8. Over here, my x now is minus 8. My y is 0. Okay, so and so on. So if we were to graph this, all you're doing now is instead of 1, right? Because before it would be a unit circle of 1, but now this is not a unit circle. This is a 8 radius circle. So I'm going to change my 1 to 8. So at 90 degrees, sorry, at 0 degrees, right? I start off at here, but at 90 degrees, I'm at 8. At 100 degrees, I'm down here to 0 again. And at 270, I'm at, for the y, back up to -8. And then at 360, I'm back down to 0. Okay, so that's my parent function graph for this. Okay. And then it says here, sketch the graph of the horizontal displacement versus the rotation of one complete rotation. Okay, so if you're looking at one complete rotation, remember we're saying vertical displacement is sine, horizontal displacement is cos. Okay, so that's what we're doing here. So, and then it's saying here, well, what's the difference between the cosine and the sine? Well, if you sketch the horizontal displacement versus the angle rotation for your car, if you're looking at difference between the sine and the cosine is a shift of 90. So in order for cos to equal to the 90, right? This cos here, this is the cos graph. If I shift this, if I shift it up to here, 90 degrees, that means I start my curve here and everything is shifted. Okay. So if it's 45 at 90, I'm going to be here. right? If it was 180 at 90, I'm going to be over here. So let me regraph that. So over here, I'm making a point there for that. And I'm going to make a point over here. Okay. And then that point goes over here like that. So if we were to graph that, let's just see what that looks like. Okay. But then I have this part, I have to come back down to here. Wait a minute. If I do that, this is not really drawn in a smooth way. I'll smooth it out. Okay. So isn't that just the same thing as the sine? Right? But I just shifted my cos over 90 degrees, right? So cos, basically a cos is the same thing as a sine, but shifted positively to the right by 90 degrees. Okay, that's what you do there. So I'm going to scroll down, so we're going to have to erase this. But you can see here, this is my cos shifted. This was my cos. Now the other one is, this is my cos right here, 8, and it's going to be cos bracket x, and it's a positive shift, so it's going to be minus 90. Okay. But then that also looks like y is equal to 8 sine x, right? It's the same, right? This and this, they're the same, right? So since they're the same, therefore, they're equivalent, okay? So if you look at, scroll down, therefore you can see that's how they're both the same, okay? So this example here is our last example we're going to look at, and then we're done. Carousel rotate at a constant speed that has a diameter of 5 meters. Horse that is directly in line with the center horizontally. This is horizontal now. If we're saying horizontal, what are we going to use? Horizontal, we use the cosine graph. Okay, our radius is 7.5 because that's half of 15. And we're going to use cosine. Okay, so here it's plotted at 7.5 as the radius. Okay, and basically it is a cosine. You can see here, I start off here, so that's a cosine. Okay. And that is, well, actually, you know what? Let's look at this one last example, and then we're done for unit 4. And then tomorrow, you guys are going to have a unit 4 test. Okay. Here is a graph of students tracking a friend. He's riding on a Ferris wheel. They know that John reaches the max height at 11 meters at 10 seconds. So it takes him 10 seconds to get to 11 meters. And it reaches the minimum height of 1 meter at 55 seconds. So I go from the max and I go to the min. Between that time, I start off at 10 seconds and I go another 55 seconds. So 45 seconds later, I get to my min. Okay. So my min, max, minus the different, minus them two together, divided by 2, my amplitude is 5. So if I'm looking at this graph, my amplitude is going to be 5. Now, it's saying here, we're trying to develop an equation. So we need our A, we need our K, we need our C, and we need our D. So our K, remember, is going to equal to 360 divided by period. Well, what's the period? Well, the period is your cycle. Okay. I start off at looking at a graph. If we look at the graph here, Start off at 10 seconds, and then it repeats at 100 seconds. Okay, if it repeats there, that is my cycle, that's my period. So 360 divided by 100 minus 10, that means 360 divided by 90 gives you 4. So my K is 4. Okay, so I know what that is. Now I'm looking at my center line, because we need to figure out what our center line is. Well, our center line is going to be our max height that we have here, minus our amplitude. Our amplitude is 5, so if I start off at 11 minus 5, my center line is going to be here. So my center line is 6. Okay, so from here, okay, because we're looking at a cosine curve. Why are we looking at a cosine curve? Because it says here we're looking at it a Ferris wheel. Okay. Well, we can look at it either a cosine or we can use the sine. Okay. And if you're looking at it from your d cos max is 10. And then in order to get your d sine, this is basically your displacement for your sine. You're gonna have to equal to d cos minus 90 divided by k. So this is the formula you need here, 90 divided by k. So now, if I'm looking at making the formula using cos, I'm gonna put here 10 for my x displacement. If I'm gonna use the formula using sine, I'm gonna use minus 12.5 as my displacement, my horizontal shift. So you can see here, I have two equations. I know my amplitude is gonna be the same. My up and down shift is gonna be the same. You can see that, it's the same. But since I'm using cos, I'm gonna look at the max. There you go, x minus 10. And if I'm gonna do the sine, I'm gonna do plus 12.5. That's it, okay? Now it's saying what's the height above the ground at 78 seconds? Well, since I'm dealing with 78 seconds, right? I plug in the value of x at 78, okay? And that's it, then I'm done, okay? So that's the last example. We are done, really we're done with, here's the practice questions. So when I go to here, go to home, we are done unit 4, guys, ladies and gentlemen, we are done unit 4. Okay, unit 4 test will open up tomorrow. I want you guys to work on these questions, practice. Here's the quiz, that's for all this stuff we did today. Here's a practice quiz that'll help you for the unit test tomorrow. And that is it, guys. You guys, like I said, if you don't hand in unit tests, you're not gonna pass. Like, keep on handing unit tests. That's how you're gonna pass. If you just think you're gonna pass based on quizzes, you fail. Okay. I'm gonna stop sharing my screen. Please go ahead, do the work. I am gonna stop recording. Have a nice day, guys.